All right, can you type that out for me? 4 over x plus 4 into your graphing calculator. On your y equals screen, 4 over x plus 4. Hit your graph button. And I want to make sure we're all on the same settings on your calculator. Is anybody not seeing this graph that I have up on the board? Because I just got to quickly change your settings. Okay, don't hit you got a zoom button up top. Hit your zoom button for me. And then hit 6, which should say standard. Good now? Is the graph coming back?
Oh yeah, actually, yeah.
Zoom 6, and then you should be able to see this graph now. Anybody else having graph and calculator issues? Okay, keep staring at that graph for me, or I have it up here as well. I need a couple questions answered back from last year when you guys took Algebra 2A. What's the domain of this graph? Before we answer that, what was domain again? Which variable, x or y? Those are your x's. So I need you to look on your graphing calculator right now. I need you to, here's how I find the domain. You just pick a point on the x-axis and see if there's a point of a graph above or below. So see, I pick this point, see how there's a graph above? I pick this point, see how there's a graph below. Is there any point on your x-axis that you can pick and look up and down and not see a graph? Take a look. Is there any point on the x-axis that you can pick, look above it and look below it, and there's no graph? There should be. Anybody see a point on the x-axis where there's nothing above or below? What is it? What's that point? You don't see anything. -4, yeah. You don't, watch. 1, 2, 3, 4, right here. I don't see anything above and I don't see anything below. So here's how you wrote the domain last year, I hope. I don't know what different teachers are doing now, but I hope x, because x for domain. Then you guys used to do this vertical bar, hopefully, such that x, well, it can't be every number, because you guys just told me what? For what number does there no graph exist? -4. So we could say x such that x cannot equal, not equal, -4. So there's your domain. Every number but -4 is in the domain, every number. All right, you ready for range, which is what value now? Your what values? Y values. So now, same thing, except you're going to look to the right and left now. So go up and down your y-axis for me. Start picking some random points and see if you can see a graph to the right or to the left of it. Is there any point on there that will not have a graph to the left or right? Is there any graph on here? Still see something there, right? Is there any point on the y-axis that you will not see a graph to the right or to the left?
0.
No?
0.
0. Well, what about that's coming awfully close but not touching? So everybody sees 0. Look to the right, to the left, there's no graph. So how do I write that now? How do you think I write the range now? Y such that y, what number didn't exist, Norm? 0. Y cannot equal 0. Great job. All right, let's keep going. Your Y-intercepts. That's where the graph crosses where? The y-axis. Everyone can clearly see it on your graph, my graph. What is that point right there?
1.
Oh, need the full point, like 1,
1.
-2, 3. What is that point right there that crosses the y-axis? 1, 0 is right here.
Oh. 1, 1.
Right here, guys. It's on the y-axis.
0, 1.
It's okay. All day today, anytime I ask you for the y-intercept, because it's on the y-axis, your first coordinate should always be 0. The second coordinate is wherever it is on the y-axis. What did you guys just tell me? Where is it? 1. So the y-intercept is 0, 1. All right, maybe some new terms here, maybe not. Asymptote. First thing, vertical. Is that side to side or up and down?
Up and down.
Up and down, vertical, right? Up and down. So what I'm looking for is a vertical. What an asymptote is a vertical line that I can put on this graph that never touches it. Like, see, watch. That's not a vertical asymptote because it hits the graph. That's not one either because it hits the graph. Is there a vertical line I could draw in right now that won't hit the graph at all? What do you think? Whoa, whoa! Where is it? Where is it? You were right. Negative. Negative. So if I draw a vertical line going through 1, 2, 3, 4, you're right. Wait, didn't we just bring that number up a couple minutes ago? For what? They're always related. Vertical asymptote, x equals 4, negative 4, excuse me, x equals negative 4. Those two will always be related. Whatever the vertical asymptote is, it's what the domain can't be. Always. Always. Go ahead, Nick.
If you wrote the answer for the vertical asymptote as like coordinates.
No, it's not a coordinate. It's a lot. There's a couple things I'm going to get real picky with. It's got to have x equals because this is an actual equation of a line. Okay, so it's got to, if you just write negative 4, no good. You got to have x equals negative 4. Good? Good point. Thank you. All right, what about a horizontal line? Could you find a horizontal line that will never touch the graph? You know, that's not going to work. That's not. Where's the horizontal line going to be?
0.
But now I'm not going to say x equals. It's going to be y equals. Oh, so what's the horizontal asymptote always related to? They go together. They go together. You find one, you know the other. You find one, you know the other. Questions? We're going to do one more. Okay, go ahead. Go back to your y equals. Everyone hit your y equals button. Clear it out. And now put in 2x plus 1 over x minus 3. Hopefully our graphs match. Domain. Can you find an x value where there is no graph above or below it? Hopefully you can. What's our highest number in here?
It was 17.
17. I know I'm going to be. We've had. Tim, what did I give you? 17?
17.
Okay, you're the new 17. All right. 8. Where doesn't exist?
3.
3. 1, 2, 3. Good job. So x, and I want it written correctly, x such that x cannot equal 3. And then while we're here, I don't care what order you go in. What do we already know now? If the domain's x cannot equal 3, what's our domain? What's our vertical asymptote then?
3.
No, hey, remember, I'm not going to cut. That's not going to cut it. X equals 3. It's a line. The line x equals 3. How about range? Range?
2.
Anything but 2. Yep. Y such that y cannot equal 2. And if we know the range, we now know the horizontal asymptote will be the line y equals 2. Any issues before I get to the Y-intercept? Because now this will be controversial. All right, Y-intercept is always 0, comma, something, right? 0, comma, something. All right, we're going to debate here. You're just going to assume it's negative 1/2? What if it's negative 1/4? How do I know if it's exactly negative 1/2? And we just can't guess. So how do I figure out exactly where this spot is right here that it crosses? I'll listen. Oh, I got a lot of hands up. Go ahead, Jared.
Maybe like the second then trace, like you know what I mean, like the minimum and maximum or intersect.
Could. I could. Others? Is that what everyone else was going to say? See it right there. Okay. I'm going to do an algebra. I'm not going to use the graphing calculator because I'm not going to allow you to use it in the next two. I'm going to do a more algebraic one here than the calculator. What's our x value here?
0.
Plug it in. Everywhere you see an x, plug in 0. That'll give you your y value out. Okay, so everywhere you see an x in the graph, the equation of the graph, put a 0, and that'll give you your exact y value. And what's that y value? Should be negative though, right?
-1.
Negative 1. Yeah, see, so that's why we don't assume it's a half. It's negative 1/3. Now look, you guys are smart kids, and you'll find out sooner or later. I'm always going to allow you to use your calculator. So it's not like I'm going to be looking over your shoulder on Friday, making sure you don't use your calculator to find the y-intercept. So if you wanted to use it, you guys brought up the trace. Even easier, you guys got a table of values, right? You go second graph. And why isn't that showing 1/3? Why is it saying 1? Oh, because I don't have the right. Yeah, never mind. I had number 1 in. You guys have this graph still in? Does it say negative 1/3 at 0? Yeah. So you can look. You can do that too. Guys, whatever gets the job done for me. All right. I'm never going to be picky. Whatever gets the job done. So you can either plug in 0 for x, or you can go to your table and see x is 0. What's my y value? All right. You guys good? Okay. Bad news now. I'm not going to let you graph anymore. But I still want all these values. Okay, I'm not going to allow you to graph anymore. How can I find these values without graphing? All right. I only need 3 values: vertical, y-intercept, and the horizontal. So take a look at 3. Don't put it in your calculator, though. Let's start with the easiest of the 3. How about the y-intercept? We just showed how we can find the y-intercept. What's going on there? It's going to be 0, comma, something. What's up?
2.
Oh, you're doing it already?
Yeah.
Easy, big dog. Yes, it's 2. Plug in 0 everywhere you see an x, and you get out 2. Again, Friday, you want to throw this in your y equals screen, go to your table, you'll see 0, 2 as well. All right, next. Now here's where I got to do some teaching. Vertical asymptote. Vertical. How can I do that without looking at a graph? You guys remember the term undefined from this unit? Yeah, it'll be on the test on Friday. Undefined is when what? Denominator equals?
0.
Okay. Your vertical asymptote is what makes that undefined. So what's in the denominator? Well, before I get there, what's in the denominator? Give me the whole denominator. So I want to know, when does x minus 2 equal 0? Remember doing undefined here with me? Way back in the early stages of this unit. So what value of x makes that fraction undefined? Go ahead and solve it. X equals 2. There's your vertical. There's your vertical asymptote. X equals 2. It's whatever makes the fraction undefined. All right, and then we still have the what? Horizontal asymptote. And here's unfortunately where we got to remember some rules. And these rules I'm going to refer to are A, B, and C right now. Okay? What's in the numerator? -4. Are there any exponents in the numerator? Okay, so if there's no exponents in the numerator, we just say the highest exponent there is 0. And I don't need you to write this, I'm just showing it up here. If no exponents exist, we say the exponent's 0. Are there any exponents in the denominator? I know they're not showing, but you see one there. There's one there. What's the exponent you see in the denominator? What's the exponent on the x? 1. Whoa, 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 whoa. Exponent, right? And we know what an exponent is, right? X to the first. So what's the highest exponent in the denominator? 1. So there was none up top, so I said it was 0. There's the highest exponent was 1 on the bottom. Which has the higher exponent? Denominator or numerator? Okay, listen to me carefully. If the denominator has the higher exponent, we say the horizontal asymptote is always y equals 0. If the denominator has the higher one. Well, what happens if the numerator has the higher? We'll get there. What happens if they're the same? We'll get there. All right, I don't want to fill your head just yet, but just know if the exponent in the denominator is bigger, it's always y equals 0 for your horizontal. Are you okay on how I determined which one had the higher and how I determined this was 0 and this was 1? We're all good? Oh, though. Bonus questions. Bonus. Part D. What's the domain? What's the domain?
2.
Oh, how do we write this now? Let's ready? Take your time, breathe. X, because it's domain, such that. What's it related to? X cannot equal. Where are we looking for the domain? Vertical asymptote, right? What was our vertical asymptote? 2. So x cannot equal 2. And then, yeah, I'm going to ask it just for this question. Range. Y such that, what do you got for me? Y cannot equal 0. Horizontal and range related, domain and vertical always related. All right, let's roll. Let's keep grinding. Number 4. Go ahead. You find the Y-intercept and the vertical for me. I'll help you with the horizontal. So start with the Y-intercept. 0 comma something. Then find the vertical by telling me what makes it undefined. And then I'll talk horizontal with you. Got the Y-intercept here for me? 8, Y-intercept. 0, -2. Great. I plug in 0 for x. Good work. Anybody got the vertical? I'll let you keep working. Vertical asymptote. X equals blank. It's got to be x equals. What makes the fraction undefined? You're not worried about the numerator. What makes the denominator equal to 0? 6. What makes the denominator equal to 0? Good. X equals 1. All good with me? We can find those two? All right, here we go. Horizontal, where I got to know the rules. Let's see if I did a decent job at this last problem. What's the highest exponent in the numerator? Great job. 1. What's the highest exponent in the denominator? Also 1. Everyone, yes? All right, so what do we notice in this one? Okay, they're both the same. So what's the rule if both are the same? If both are the same, it's going to be the numbers out in front divided by each other here. So what number's out in front in the numerator? 4. What number's out in front in the denominator? So if the exponents are equal, you divide them. You divide the numbers out in front. So this would be y equals, what's your horizontal one? Y equals 4 divided by 1. So y equals 4. Only if they're equal, I divide the leading numbers out in front. Any issues yet? Before I get to 2 more. We're okay? Okay, next one. I just want to hit all the different types you'll see. Go ahead, Y-intercept first. And I'll do vertical with you on this one. Y-intercept, 0, comma. You're plugging in 0, right? $13, 0, comma. 1. Sure. Who had that? Sydney? You plugged in 0, right? So you get 2 on top, right? And then you get -2 on top, -1 on the bottom. So divide those. We sure? Okay, everyone else, 0, 2, Y-intercept. You good? You sure? All right. Let me know if you're not. I can explain it. All right, you ready for the vertical? Where it's undefined. What's in the denominator? When is x squared minus 1 equal to 0? That means it's undefined. Okay, we've done a lot of this unit. What can I do with x squared minus 1? Factor it. Difference of 2 perfect squares. So really, hey, I'm not just going to have one vertical asymptote. I'm going to have 2 of them here. And that's all right. It happens. Because this is where it's going to be undefined. What's one vertical asymptote? X equals -1 and x equals +1. Yep. So yeah, you might have 2 if you have to factor the denominator. And here's our last scenario for horizontal. What's the exponent up top? Highest exponent up top? 4. Bottom? 2. So now the numerator is bigger than the denominator. Numerator bigger than the denominator. Ready? There is none. No horizontal asymptote. If the numerator's exponent is bigger than the denominator, there's no horizontal asymptote that exists. None that exists. Meaning you cannot draw a horizontal line in without hitting the graphs. None exist. So yeah, it's challenge time. Who's going to dig deep here? If there's no horizontal asymptote, what's your range then? Because those are always related, right? Think about it. There's no horizontal, none. It's not there. So what do you think my y values, my range would be? What's up, Dylan?
I have like I'm not sure it was like
Yeah,
y such that y like is not real or something like that.
You're close.
Okay.
You're close. Hey, no horizontal asymptote means every number is in play, right? I don't eliminate any number. Every number is in play. So the range here would be y such that y is all real numbers. You probably had a fancy symbol. I don't care about that symbol. Because think about it. The asymptote means you can't have it. So all numbers are in play. All numbers are in play. All right? Thanks. We all good? The domain would be what? I won't write it, but x such that x cannot equal -1 or +1. All right? Questions? All right, we got one more, and then you're going to go flying in your textbook. I got a quick question from last year before we start. This is what we've been doing all day, right? Do you remember last year when I do -8, what happens to this graph, the effect it has, -8? -8. What happens to 3 over x minus 7 when I subtract 8? -8. It goes down 8 units. So keep that in mind when we're finding these values, okay? This graph is going down 8 units, all right? Keep that in mind. That will affect something here. Not everything, but it will affect something. Let's start Y-intercept. Go ahead. You guys know the deal there. Come on. Go ahead and find the Y-intercept. That's no issue. We found it. It's going to be found the same way as we've done in class. And yeah, it's a freaky fraction, isn't it? But it's fine. You're correct. You didn't do anything wrong. Try to leave it as a fraction for me. 0, comma, plug in 0, get the y value out. It's a freaky fraction. It's fine. Relax. Plug in 0. 7, when you get it, let me know. Is there a 7? Am I just going to be waiting for no silence? Okay. 6. Go ahead, plug in 0 everywhere. So 3 over 0 minus 7, and then -8 on the outside. Should give you a decimal, or you can change it back to a fraction. Or remember what we did too. You can type it into y equals, then go to your table too, and see what your y value is at 0. Yeah, that's fine. It's correct. -59 over 7. All right, let me go vertical now. Vertical asymptote. Where's the fraction undefined? Remember, where's the fraction undefined? Yep. When the denominator equals 0. So let me know the x value that makes the denominator equal to 0, because that's my vertical. 10. 6 again. Yep, good. Now, hey, real quick. We just said the -8 moves the graph down 8, right? But this is a vertical asymptote. Do you think that affects it at all? Moving the graph down? No, because it's vertical. I'm moving the graph down 8, so the vertical asymptote not affected at all. So let's keep going. If you know the vertical, let's go. What else do I know? Just pushing it all together today. If you know the vertical asymptote, now you know the darn what? Domain. Write it. X such that X such that. What's my domain? Let's roll. 13. X. There you go. Good. X cannot equal 7. Perfect. Final thing. Horizontal. That's where we got to use those 3 rules on the other page. Okay, take a look. What's the exponent in the top? 0. There is none, right? What's the exponent in the bottom? 1. Which one has the higher one? The denominator. So we just got to remember the rules. If the denominator has the higher exponent, what do we say the asymptote is? Y equals 0. Whoa. Y equals 0, but what did we do to the graph? Is that going to affect the horizontal now? Darn right it is. All right, this was the horizontal asymptote for this right here. But now I shifted it down 8, so it's not y equals 0 anymore. It'll be y equals -8. Yep. So that shift only affects your horizontal. Okay, that shift would only affect the horizontal. And then finish this off strong. Now that you know the horizontal, what's your range? Y such that, let's finish this off. 2.
Y with like the equal and the cross out line, -8.
Not equal to?
Oh yeah, not equal to.
Good, good. Yep, good words. -8. Yep. Whew. All good? All right, let's roll. Grab a textbook. You might be able to finish this thing before you leave today. Check your answers on Classroom. Come on, let's go. Share a Chromebook or answers between you and everyone in your group. I don't care. You do not graph. You're finding everything we found all day today. Do not graph yourself. And then look on Classroom for your answers. Here we go. Whew, solid session today. Good session. Popping this up on YouTube here, Jake, and you can take a peek at it whenever you have time.